price of Romex has been rising steadily across the United States due to several factors. Firstly, there is increased demand for home renovations and new construction. Secondly, supply chain disruptions caused by COVID-19 lockdowns have contributed to the price increases. Thirdly, the rising costs of raw materials such as copper are also a factor. Finally, general inflation is impacting the cost of goods. In addition to these national factors, Alaska also faces unique challenges that contribute to higher prices. Shipping materials to Alaska is more expensive due to its remote location. The relatively small population of Alaska means lower demand for electrical supplies, which can lead to higher prices. There are fewer hardware stores and electrical supply companies in Alaska compared to other regions, which limits competition. It is difficult to say definitively whether the prices are higher than elsewhere without knowing the specific locations being compared. However, the prices listed $23.99, $39.99, $54.99 and $64.24 for 250 feet of 12mm wire are significantly higher than what is currently being charged in many other parts of the United States. There may be a shortage of Romex in the area, or demand may be particularly high. Some hardware stores may be marking up prices to take advantage of the current situation. Delays in shipping or other logistics problems could be contributing to higher costs. To mitigate these high costs, compare prices from multiple hardware stores and electrical supply companies to get the best deal. If Romex is too expensive, consider exploring other wiring options such as NM cable or MC cable. If possible, purchase Romex in advance when prices are lower to avoid paying inflated prices later. When evaluating wiring options, it's important to understand the differences between Romex, NM cable, and MC cable. Romex is a brand name for non-metallic sheath cable, commonly referred to as NMB cable. NMB cable is typically used for residential interior wiring for lighting receptacles and switches. It consists of 2 or more insulated conductors and a ground wire wrapped in a plastic jacket. NMB cable is suitable for dry locations only. It should not be used in damp or wet locations or exposed to direct sunlight. MC cable, or metal-clad cable, consists of insulated conductors encased in a flexible metal sheath. MC cable offers more physical protection than an NMB cable and can be used in exposed or concealed locations, both dry and damp. It's often used in commercial and industrial applications, as well as in residential settings where greater protection is desired. When comparing the costs of NMB cable, also known as Romex, and MC cable, several factors come into play. NMB cable is generally less expensive than MC cable due to its simpler construction and materials. MC cable requires a metal sheath, which adds to the material cost. The labor costs for installing an NMB cable are typically lower than for MC cable. NMB cable is easier to cut, strip, and route, which can save time and effort. MC cable requires specialized tools for cutting the metal sheath and installing connectors, which can increase labor costs. Choice between NMB cable and MC cable depends on the specific application and local electrical codes. NMB cable is suitable for most residential interior wiring in dry locations. MC cable is preferred in situations where greater physical protection is needed or where required by code. When evaluating the cost-effectiveness of different wiring options, consider the long-term benefits of each type. MC cable offers greater protection against physical damage, moisture, and rodents, which can reduce the risk of electrical problems and the need for repairs. NMB cable is more vulnerable to damage and may require more frequent replacement in certain environments. Always consult with a qualified electrician to determine the best wiring option for the specific needs and budget. An electrician can assess the project requirements, local codes, and environmental factors to recommend the most appropriate and cost-effective solution. Before making any wiring changes or upgrades, obtain the necessary permits and approvals from local authorities. Electrical work must comply with the National Electrical Code, NEC, and local building codes to ensure safety and prevent violations. When comparing the prices of electrical supplies, be sure to factor in all the costs involved, including materials, labor, permits, and inspections. Sometimes the cheapest option upfront may not be the most cost-effective in the long run. The rising cost of copper is a significant factor driving up the price of Romex and other electrical wiring. Copper is a key component in electrical conductors, and its price fluctuations directly impact the cost of wiring materials. Several factors contribute to the rising cost of copper, including increased global demand, supply disruptions, and geopolitical events. As emerging economies like China and India continue to grow, their demand for copper increases, putting pressure on global supplies. Labor strikes, mine closures, and natural disasters can disrupt copper production and further drive up prices. Political instability in copper-producing regions can also affect supply and prices. To mitigate the impact of rising copper prices, consider using alternative wiring materials that require less copper or that use alternative metals. Aluminum wiring is a common alternative to copper wiring in some applications. Aluminum is less expensive than copper, but it has a lower conductivity and requires larger gauge wires to carry the same amount of current. Copper-clad aluminum wiring combines the conductivity of copper with the lower cost of aluminum. This type of wiring consists of an aluminum core with a thin layer of copper cladding. Fiber optic cables are another alternative to copper wiring for certain applications, such as data transmission. Fiber optic cables use light to transmit signals and are immune to electromagnetic interference. When comparing the costs of different wiring materials, consider the long-term performance and reliability of each type. Copper wiring is known for its excellent conductivity, durability, and resistance to corrosion. Aluminum wiring is more susceptible to corrosion and may require special connectors and precautions to prevent oxidation. Always follow the manufacturer's instructions and local electrical codes when installing any type of wiring. Improper installation can lead to electrical hazards and void warranties. Consider the impact of wire gauge on the ampacity, which is the current carrying capacity of electrical wiring. The ampacity of a wire is the maximum amount of electrical current that it can safely carry without overheating. The NEC specifies the ampacity of different wire gauges based on the type of insulation and the ambient temperature. Thicker wires have a higher ampacity than thinner wires. When selecting the appropriate wire gauge for a particular circuit, it's important to consider the load requirements and the length of the wire run. If the wire is too thin, it can overheat and cause a fire hazard. If the wire run is too long, voltage drop can occur, which can reduce the performance of electrical equipment. To determine the appropriate wire gauge for a circuit, consult the NEC tables and guidelines. NEC Table 310.15 B16 provides ampacity ratings for different wire gauges based on the type of insulation and the ambient temperature. Use a voltage drop calculator to estimate the voltage drop for a particular wire run. If the voltage drop exceeds the recommended limit, increase the wire gauge or shorten the wire run. When running electrical wiring through walls, ceilings, or floors, follow the NEC guidelines for protecting the wires from physical damage. Use conduit or cable trays to protect exposed wires. Secure the wires to studs or joists using cable staples or clamps. Avoid running wires through sharp edges or areas where they could be damaged by nails or screws. When making electrical connections, use approved connectors and terminals. Ensure that the connections are tight and secure to prevent overheating and arcing. Use wire nuts or crimp connectors to join wires together. Use terminal blocks or lugs to connect wires to equipment or devices. Always turn off the power to the circuit before making any electrical connections. Use a voltage tester to verify that the circuit is energized. Follow proper lockout/tagout procedures to prevent accidental energization of the circuit while working on the electrical system. When working with electrical wiring, always wear appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. Avoid working in damp or wet conditions. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Electricity can be dangerous, and improper wiring can lead to serious injury or death. Stay informed about changes to the NEC and local electrical codes. Electrical codes are updated regularly to reflect new technologies and safety standards. Attend training courses and seminars to stay up to date on the latest electrical practices. Consult with the electrical inspectors and building officials to ensure that your electrical work complies with all applicable codes and regulations. Remember that electrical safety is everyone's responsibility. By following proper procedures and guidelines, you can help prevent electrical accidents and ensure the safety of yourself and others.